Hello everyone, we will solve this today's LeetCode weekly contest problem. This is the third problem, minimum length of anagram concatenations, right? So let's see what it is. So it is a given, you are given a string S which is known to be concatenations of anagrams of some string T. We need to return the minimum possible length of the string T and the anagram which is found by rearranging the letters of a string, for example, AAB, ABA. We are anagrams of AAB, right? So what are the anagrams? Anagrams. So anagrams is something that uh, right, suppose this is given ABC, so the anagrams of this ABC is that we can change the positions of all the characters and make separate another strings. That's are all are the anagrams of this ABC, right? So like CBA, ACB, BCA, these all are the anagrams of ABC, right? So this is like the anagrams, right? So what we need to do, we need to find the minimum possible length of string t, any string t, which has concatenate. If we combine all the anagrams and make this string as a whole, right? Okay. So what should be the first thing which comes in my mind after reading this, that I need count of the string, not exact string. So that I need count of the string, right? Not the exact string, right? That's the first thing we need to observe, not the exact string, right? Okay, the second thought which comes in my mind is, uh, how will I need to find the length, right? Minimum length for this. So I need to count the characters, and there are only 26 characters, 26 characters, 26 alphabets in the 26 alphabets, right? So how can I find the, if you see the constraints, the constraints are 10 to the power 5. So how will I find uh, the minimum length, right, which can give me concatenations? So after that I started thinking of that how will I how will I rearrange it, and so that I can find so that I can get every characters when we concatenate all the uh, strings, right? So for that I thought of counting characters, right? I thought of counting the characters, and after counting characters, like count all the I will count all the characters which is present, which is present in the string, and check that how many characters are uh, that how what is the minimum number of characters which give me the strings concatenation. So if you see here that ABBA, suppose this is A again, AB, this is ABBA, right? And suppose so in this A is currently occurring two times, B is currently occurring two times, right? So for this, if you see the minimum number of characters is 2, right? Both are occurring two times. So what should be the minimum number of characters present for A? So that can be only A, that is one. For B it can be B. So what is so suppose there is also given CBA. So for C this is also be true, and for C ABC can be the anagrams. So if you see here that we count all the characters which is present in the string, and find the GCD of all the characters, right? Find the GCD of all the characters, right? Characters. So it becomes GCD is equals to here 2. And now what I am doing, that I will divide all the occurrences with GCD, so that I can find the minimum number of minimum number of the characters I need for to make this string as an anagram, right? So what I do, I will divide all the number of characters with this. So 2 by 2 is 1, b to 2 by 2 is 1, again C is 2 by 2 is 1, which is, after summation this becomes 1 plus 1 plus 1 plus 1 is equals to 3, which is answer is 3 for this ABCB, right? But uh, in this, something is missing, right? In this, something is missing. What can be the case? Why is it not working for some of the cases? Although it get accepted in contest for many of the peoples due to some weak test cases, which that's why I'm just I'm just each case are two this case are missing, so incorrect. I'm just giving dislikes to this, right? So I'm submitting. Uh, okay, it's not getting submitted. Why? Uh, so test cases are missing. Right. I will tell you why I'm disliking this. This should be submitted. I don't know why it is not submitting. Uh, Others submit. I don't know why it is not submitting. So I'm disliking this. Right. Why? Because its test cases are very weak. Due to test cases, these are very weak. Many have submitted these solutions and got accepted, which is quite disappointing here. But so why it is why GCD will not work, right? Why GCD will not work here, right? So if you see, if you take example like what we are doing, we are counting all the characters. So if you see AAA, BBB, CCC, right? If I take these characters, so according to our approach by taking GCD, what should be the answer here? So suppose here 4 A's, 4B, and 4C. So A has 4, B has 4, C has 4, right? So after this, if I check what will be the GCD, GCD will be again 4. And after that, what I will do, we will divide this 4 by again. So answer will be 4. 1 plus 1 plus 1 plus 1, right? Or answer will be 3, right? So do you think that if I take three characters and concatenate all the anagrams, will I get this string, right? If I suppose I take ABC, so its anagrams is BCA, CAB. So if I concatenate add all the strings ABC, CBA, ABC, will I get form this? No, of course not. So this is the edge cases which is missing in this problem. So this GCD will not work. This GCD will not work. Fine. This GCD will not work here. So now the question is how we will solve this problem, right? So definitely we can solve this problem by taking every length and check that whether this length is possible to check this anagram concatenation or not. So it is just like a brute force approach. It is just like a brute force approach. So what we will do, we will check that. So let's take this example, which is creating problem. It is ABCCC. So what will I do? I will check for every length from 1 to 1, and will check that whether all the characters within the current length are equal or not, are equal or not. So if at any length my all the characters are present, all the characters are present, number of characters are present, number of characters are present for that length in my whole string, in my whole string, then that length will be the answer, will be the answer. Why? Because we need to find the minimum length, not maximum length. So the first length which give me all the characters same for my whole string, that will length will be my answer simply. Because that's because I am starting length from 1 to n, right? For each length, right? From 1 to n, not from n to 1, right? So that's the minimum length which I get the first answer. So how we will see this, right? So the first thing which I need to which we need to remember, that this length of a string, this length of a string should be, must be divisible, must be divisible by the length we choose. Length we choose. Why I'm this why I'm claiming this? Because suppose I have chosen, I have I am I have chosen the length 2, right? I've chosen the length 2. So if I've chosen this length 2 and the my string length is my string length is 5. So this 5 is can never be divisible by this 2. So suppose I have a string like ab, and the string length is a b c b a. So this is never can never be divisible by this ab, because after the concatenations this can become ab aba ab ba ab ab. So this will be the multiple times of 2 only, right? This can't be divisible by, so 5. So we will check the divisibility condition that this string length should be divisible by this 2, right? So that's why this length of the string must be divisible by the length we choose for the answer, right? For answer, for answer, right? So the first condition is that due to this. The second conditions, what will we do after checking this? After checking this, what will we do? We will check the count of the length we choose, the count of characters of a string till length we choose, right? So and then what we will do, we will check, and then we will check the count of all characters, count of all characters for each segment of that length, each segment of that length. What I mean is, suppose this is a b b b, suppose a b c b c a c a b, right? So what does it mean? Suppose I have taken the length 2. Suppose I have taken this length 2. So I have stored all the characters of this 2 length ab in my vector of 26 or something array, and we will check for this 2 again, fit then this 2 again, and this 2 again, right? So this is how we will check for every two length string, that whether this all the characters have the same length or not, right? So suppose I have taken 3, and this 3 is 3 3 6 3 9. So string length is 9. So this 3 is divisible by 9. So the first condition satisfies. Now we will check for every 3 length that whether this 3 has similar number, same number of characters or not. So for this 3 ABC occurring one times. Now we will check this BCA. This is again occurring one number of times ABC. Now this is CAB again occurring one number of times. So this length 3 is possible answer, right? So this is how we will calculate all the answers, right? So this is, now we will need to implement this. So just let's implement this. Let's see how we will we can implement this. So now, so what we need to do, we will need to start iterating for checking the length from starting one point and till n, because the maximum possible length will be n. So we will start iterating from 1 to n, and then what we do, we will need to take a array to store all the characters, right? Then we will start we will start adding all the number of characters of starting this length with this length, right? So what will this, we will store this length here, s of j minus a. Okay, before that I need to check this first conditions. Just need to check this first condition whether this is divisible the length we choose or not. So before that I need to check that this is length is divisible by this length or not. Otherwise we will not check this again, right? Because there's no point of checking this if the length of this is not divisible by the chosen length, right? So this need to be checked before. Now we will check for every for every segment of string which is a part of this length. So we will store every characters in this array. Now what I will do, I will check for every part, like this three length, so ABC, this BCA, and this CAB. This whole three segments length will be need to be checked, right? So we will start from where? We will start from this length part, right? Because why we'll start from this length part? Because we have already seen this, that this character should be matched. So we will start from this length, and we will move till n, and we will increment this length every time, right? And for every length part I need to store all this. So we will start iterating from this j, then this k should be j plus length. Why this j plus length? Okay, so for the what is this, this should be started from this length part, right? So suppose we have chosen this length as 2, right? So we will store all the characters from 0 to 2. Now from we will start from 2th value, so 2, and for this 2 we will iterate till 3 value, so 2 3 4. Okay, so we will store all the characters, we will store all the characters from this v1, so v1 s of k minus a, right? And we will store all the characters till this length in my second vector, right? So after storing all the characters for this, we need to check that whether this whether this vector and this starting vector length is number of characters is same or not, right? So for this I will just check that whether this v1 of k is, if this is not equal, then what we do? If this is not equal, it means this length is not possible. If at any point, if it is not possible for any string, then it is definitely sure that this length will not able to make anagrams for making this a string, right? So starting we will make this f0, and if this is not equal I will mark this f1, and this is should be the break here. I will break this here, and after this if I will again break this, because this length is not possible anyhow. If I there's no need to check every length, because if I get f is equals to 1 at any time, right? And I need to check for this also, that if this is not, if I get all the characters same that I need to store, then I need to just return this length. Why? Because this is the first length, and this will be the minimum length after that, and I will just return here from 0. Right? So this is something, some weird implementation. This can be simplified as well, right? This can be simplified. This is some weird implementation. This is how I implemented the code. This can be more logical, and this can be more simplified by making functions. But this is how I implemented the code during virtual contest, because I've not given live contest. So this is how I implemented the code in virtual contest, right? So what we have done here, we are iterating for we are checking for every length, and we are checking for every length part from choosing from here, right? So okay, just run this. Let's see whether it is working or not. uh, some net issues. It is just like brute force approach. Okay, now run this. Some net issues are there. Let's again run this. Some net issues are there. Mm, okay, we have passed the test cases. Let's submit it. Yeah, we have successfully submitted. So we have just checking each and every length for this. So what will the time complexity in the space complexity? The main analyzation is this for this, because if you analyze before this approach, this time complexity, that question will be an easy one for this, right? So what we are doing, we are checking for every length this condition. So what this condition means, that every length should be, every length is, can be divided this n, right? So at worst case, what can be, it's this is can be done for root n, right? If you know that a particular element can be divisible by only root n times, right? Can be divisible by only root n times, right? So that will be root n for that conditions. So uh, square root of n, how will I write this? Okay, that will be square root of n, right? And for every square root of n, what we are doing, we are iterating in whole array, right? A whole string, right? So how, because this, we are iterating for every length 0 to j to n, so first 0 to length, then j to length, then from j to j plus length, right? Because we are iterating for every divisibility, we are only iterating one times this string. Why? Because this j to j plus length, and we are adding this length, jumping this index to again after this length. So this whole is only o of n, right? This o of n, so this will be o of n into root n, right? So this is square root of n into n, the time complexity, and the space complexity will be, so we are taking only this 26 extra array for storing the count of characters. So that will be O of 26. So this will be again O of n into square root of n. So this is O of 26, that will eventually take O of 1, right? So this will be the time and the space complexity for this problem. So in contests, many of the people find GCD as their first approach and mark this before, no, and don't think this edge cases, this AB and the edge cases, right? And they are only weak test cases, so they get accepted. But eventually, after adding these test cases, ABC or like this, A B B B C C C, or A B C C C X S S, like this type of strings, adding test cases, this GCD will not work, right? So this solution is the optimal one, I think. If I don't think anything, because n root n is like something 10 to the power 5 and 10 to the power 7, right? So 10 to the power 8, like something though, that will be, that should be acceptable, right? So this is how we will solve this problem. Thank you, hope you understand. Bye bye.